Hi, my name is Martin, and this is a video about my experience in robotics and computer science. First, let me talk about how I learned some of my robotic skills. Since I was really young, I was really interested in various kinds of design and creation. Later on, in 7th grade, I discovered 3D CAD design. In 8th grade, I took the APCSA course and found Java programming really appealing. It was a higher level programming language and provides far more classes and things to do with it. With the knowledge learned in the course, I used the JetBrains IDE to explore more out of Java, such as using the Java API and to explore more classes. In the second trimester, I recruited the base's first FTC team, Team 2656, with a total of 10 team members with an average age of less than 13 years old. It was a very young team. I was voted as the team captain and responsible for the overall organization, software design, commissioning, and I was also one of the robot controllers on the field when the competition is going on. The entire system of the FTC is composed of three main parts. One is mechanical, the other is control, and the other is remote control. These three components are all crucial to the functionality of the robot. This is our first prototype, relatively simple, mainly used for experiments and completing some basic actions. The chassis is built by two omnidirectional wheels and two ordinary wheels, all provided in official equipment. This is the official robot which participated in the competition for the first time. This chassis uses the Magnum wheel, which is more maneuverable, uses stretching mechanisms to grab the relic, uses two rubber wheels to suck up the glyph, and uses two rails to lift up one or two code blocks, and to transfer them to the crypto boxes. In this competition of the qualification match stage, we ranked 12, and unfortunately formed an alliance with the team 5858, who ranked first at the time, and we finally won the runner-up, which is really fortunate. And a week after the Shenzhen competition, we participated in the Guangzhou regional competition and won 10th place in the qualifier stage. Then we formed an alliance with second and third, and we got the highest score in the game, which is pretty fascinating considering it's the first time we ever teamed. And in the preparation for the national competition, we have made a lot of adjustment in more than a month, such as redesigning the automatic phase to complete 3 steps of sucking the cipher block, designing the relic claw by using the 3D software, and printing the parts using the 3D printer. This was commissioning the situation of the national competition on site, and the waiting situation. After the adjustment, our robot completely renewed, and performed very well. This was the first game, and we got 2 blocks in the automatic phase, the mechanism that picked up relic using semi-automatic technology, in which people control the key points, and the program automatically stretches and retracts. This was another competition. We negotiated with the partner team, and we worked together to get the relic gold. In this game, we took 2 relics. In the national qualification competition, we won all 6 games and scored 12 points, ranking 3rd. As the captain of the league, I chose the other 2 teams, the best 2988 and team 5858. Finally, we met the final team, and in the semifinals, we missed the championship. This was a photo of us and the other 2 teams. It was really exciting, but last we didn't win the championship. The control program is developed using Android Studio, which is based on Java. And actually, I've learned Java in 8th grade in the APCSA course, so that came into handy. I was responsible for the overall framework of the program, and also the organization of the different parts and classes inside the software. Different physical components in the robot are controlled by different Java classes. In this way, the hardware person and the software person can correspond to one component, and they can relate to only one class, and they can develop their own part independently, which is very convenient for division of labor and cooperation. The components of the robot mainly include the chassis drivetrain class, the glyph arm class, which is responsible for transmitting code blocks to the lock block, and the glyph catcher, which is the suction mechanism responsible for sucking or withdrawing the code block. The jewel arm class is the program for jewelry identification and kicking mechanism. Relic arm class is the telescopic mechanism and the crawling of the relic program. View Mark ID class is a graphics recognition program that recognizes 3 different patterns in the left, center, right, and needs to be used in the automatic stages. These programs are corresponded to different physical parts. Different project members can be assigned to different parts in the whole project, and each of them are responsible for a specific thing, so we can all work together with more efficiency. After the hardware and software of these basic physical components are completed, we use automatic programs and manual programs to call. For example, the teleop test class is a manual program which uses a lot of basic classes, initialized in front, and then according to the manual control logic to carry out related design. The automatic program is also the same, and will also use the functions in the same base components class. This is the overall control of the FTC robot program.
Thank you for watching this video. I believe I have the ability to lead a team into different activities, and I'm sufficient in knowledge in both software and hardware. I really wish I could be a part of the robotics program.